Okay, we're going to continue here with the arc length questions. So what we have here is question number 6. We've got to find the arc length of this curve over the interval from 1 to 3. So over here, x is 1. Over this particular interval, x is 3. And we want to find the length here, s, starting from these 2 points on the curve. And your function here is going to be 9 minus 3x. So, as we seen earlier today, let's get out some paper. Arc length is the integral from 1 to 3, square root 1 plus y prime squared dx. So when your function here is y equals, because y is f of x, 9 minus 3x, we're going to have to find that derivative. Okay, so y prime is going to be derivative of 9 minus 3x, which is going to be negative 3. So now, by looking at 1 plus y prime squared, you get 1 plus 9, which is 10. And again, we got to take the square root. So what this means is the arc length will be the integral from 1 to 3, square root of 10 dx. And we can pull out the constant. And now we get the integral here. This will be x from 1 to 3. So our arc length, square root of 10x, from 1 to 3, this is going to be f of 3 minus f of 1, square root of 10 times 3 minus the square root of 10 times 1, or 3 square root of 10. Oops, let's be careful. Yeah. This will be 2 square root of 10. Okay. So the arc length will be 2 times the square root of 10. Okay. I'm going to shut the door over here. Okay. All right. Now that leaves us to question 7. And question 7 is going to be different than questions 1 through 6. Here's the difference. We have what's called an asteroid. Okay. You have this special relation. So you're looking at a relation. The other curves that we worked with were all functions. But you might say, well, how are we going to go about finding the arc length around this whole curve here? This is the curve C. Sorry, this is the curve. It's not C, it's the curve. So, okay, how are we going to find that? Well, here's what we're going to do. We're going to find the distance here between these 2 points. This will be what we're looking for. This is our S. We're going to try to find that here. Okay, arc length here, S. And if I can find that distance, arc length, because of symmetry of this curve of the asteroid, it's really going to be 4 times. Okay. Integral from 0 to 1. This is the distance in blue. It's going to be 4 times the 1 plus 1 prime squared dx. Okay. So we're going to have to find y prime for this relation. Now, what you do is you have to use implicit differentiation. So remember, to get y prime, we're going to use implicit differentiation on that curve. So d dx, x to the 2/3 plus y to the 2/3 is d dx of 1. Okay, so the derivative of a sum is sum of derivatives. Okay, so let's actually find this derivative. So 2/3 minus 1 plus 2/3 y to the 2/3 minus 1 times y prime equals 0. Okay. And I can, divide both sides by 2/3. What happens is this 2/3 goes away. We're going to have x to the, let's do some arithmetic now. Okay. 3/3, 3/3. So we get x to the 2/3 minus 3/3, which was negative 1/3, plus y to the negative 1/3 times y prime will be 0. Which means y to the negative 1/3 y prime is negative x to the negative 1/3, or y prime is really negative x to the negative 1/3 over y to the negative 1/3. So that y prime becomes negative, I guess we can write it this way, y to the 1/3 over x to the 1/3. Okay? So we found some important information here. We got y prime now. Now, don't forget, what we have to do is take this derivative, we square it, and we add 1 to it. So you get negative y to the, we're going to square that derivative. So that y, let's see what we end up here. We get 1 plus now y to the 2/3 over x to the 2/3. Now I'm going to have to do some algebra here. So let's go back. Let's go back and consider, let's note something here. That the original curve, the original relation that they gave us is x to the 2/3 plus y to the 2/3 equals 1. So this is the relation. It's an asteroid. We're trying to find that distance. So what we can do is solve for y to the 2/3 And what that gives us is y to the 2/3 will be 1 minus x to the 2/3. So this is what we're going to substitute for our y to the 2/3 here. 1 plus now y prime squared becomes 1 plus 1 minus x to the 2/3 over x to the 2/3. Okay, because we replace that original equation with 1 minus x to the 2/3. This is what the y to the 2/3 is really. All right. So now we're going to have to add a whole number with a fraction. So remember what we can do. We can replace this 1 with x to the 2/3 over an x to the 2/3. And now we end up with here 1 plus y prime squared becomes x to the 2/3 plus 1 minus x to the 2/3, everything over a single x to the 2/3. Now, that's pretty nice because we get cancellation here and here. So this is now 1 over x to the 2/3. So don't forget now we take the square root here because that was the whole purpose of going through this formula here. Okay, so this is where we're at. But don't forget, we're going to have to multiply that by 4 because they want the whole length of the asteroid. So it's 4 times that integral. Okay. Let's write this down. Arc length will be 4 times the integral from 0 to 1, square root 1 over x to the 2/3 dx. So we can do a little bit of algebra here. And that algebra is going to give us the square root of 1 over the square root of x to the 2/3, 1 over x to the 2/3 times 1/2, which is 1 over x to the 1/3. This is what we have. So that the arc length will be 4 integral from 0 to 1, really x to the minus 1/3 dx now. So we're going to replace that integrand. It's really 1 over the cube root of x. So this is now a very good and simple integral to perform. And let's multiply that by 4. 4 x to the negative 1/3 plus 1 over negative 1/3 plus 1. We evaluate that from x is 0 to x is 1 3/3. 3/3. 4x to the 2/3 over 2/3 from 0 to 1. 4 times 3/2 x to the 2/3 from 0 to 1. We're going to need more paper. So, looks like we get 2 times 3. This is 6. X to the 2/3 from 0 to 1. Don't forget, this is antiderivative. Evaluated 1 minus 0. 6 times 1 to the 2/3 minus 6 times 0 to the 2/3. This portion here is just 0. And by the way, 1 to the 2/3, that value is 1. So it looks like here, the arc length is going to be 6. All right. So that's the total distance around this curve called the asteroid. It is a relation. You say, why is it a relation? Because of the, sorry, it's a relation, ladies and gentlemen, because we have what's called the vertical line test. Okay? That vertical line test makes this a relation. And let's actually draw a nice vertical line. And that's the distance in red are along that curve here. So we have to use implicit differentiation, vertical line test. And distance is 6, I guess. Okay. Now, take a look at the next question here, number 8. We got determine the length of the curve 9y squared equals x times x minus 3 squared from 0 to 3. And this is going to be a key idea here for us as well. The y values are greater than 0. And what that really means is they're talking about being above the x-axis, this particular curve that they gave us, they described here. And the values of x are between 0 and 3 here. Okay. They want us to find that distance starting here from x equals 0 at this location to this point where x equals 3. We're going to find that arc length. So the arc length is going to be found by integrating from 0 to 3, the square root of 1 plus y prime squared dx. And yes, okay. Now, here's what we have. We have the curve 9y squared equals x times x minus 3 squared. Now, graphically speaking, this is not a relation by looking at this particular curve, because by the vertical line test, you only hit that curve in one spot. So this is really not a relation, but the function, or I should say the equation here that they gave us, did really come from a relation, because you have the power of y to the second power and really the power of x to the second power, but it's really a higher power that's going to be a third power. So, okay, they just only gave us part of a relation by restricting the domain for x to be 0 to 3 and then y to be positive or 0. So they restricted the domain of a relation. So this is a restricted domain for a relation. But the portion of the curve you see is really not a relation, because it doesn't fail the vertical line test. So we're still going to use, however, and we still can use implicit differentiation. So here's the deal. d dx of 9y squared is d dx of x minus 3 squared. So remember, by implicit differentiation, this would be 18y times y prime on the left, and on the right, it looks like we're going to have to use product rule, which will be d dx, we're going to pull out the x minus 3 squared plus x minus 3 squared d dx of x. So let's find what that derivative is. Let's get some paper. And I guess here by chain rule, you have 2 x minus 3 times 1. And over here, this is just 1. So let's see what we have all together. We have 18y, y prime on the left will be 2x times x minus 3 plus x minus 3 squared. Solving for y prime now, we'll have 2x x minus 3 plus x minus 3 squared. So this is divided by the 18y. I'm going to do a little algebra in the numerator. I'm going to factor out the x minus 3. You got 2x plus another factor of x minus 3, and this is over 18y. So we get x minus 3 times 3x minus 3 over 18y, x minus 3 times 3, over 18y. Let me give a message here. Okay, let's kind of be careful here with this. Make sure everything's good to go. So that'll be a 6. So we have now y prime equal x minus 3, x minus 1 over 6y. Okay. Now, don't forget, now we have that y prime. That's some pretty good progress here. Okay. Okay, so we found the derivative, and now let's take 1 plus y prime squared, 1 plus x minus 3, x minus 1 over 6y squared, one plus x minus 3 squared, x minus 1 squared over 36y squared now. So let's try to see what we can substitute now for the y squared by going back to the original equation. And you go, oh yes, what do we know? That 9y squared is actually x times x minus 3 squared. So y squared, let's try to fit this in so we can see that here. Y squared is x minus 3 squared over 9. And then keep in mind that our y value will always be greater than or equal to 1 because of our restricted domain for this relation, although the graph portion is a function. All right, let's see what we can do with this. Do a little algebra here on this. We're going to need more space here. Okay. So we get 1 plus x minus 3 squared, x minus 1 squared over 36. Now times the y squared, which would be x x minus 3 squared over 9 here. So all we did was substitute what y squared is here. So let's do a little simplification here. 1 plus, so this will be a 4, x minus 3 squared, x minus 3 squared. We get 1 plus x minus 1 squared over, looks like we have 4x. So let's double check. And now we can add here. We replace 1 with 4x over 4x. So let's see what we get. 4x plus x minus 1 squared, everything over the 4x now. Okay. Let's double check everything is what it should be. Okay. So if we take the square root now, we have to be able to integrate what's under that radical. So we may need to see if we can do some algebra over here in any way. So let's try some algebra. Okay, let's see if we can simplify that to some degree. 4x plus x minus 1 squared over 4x so we get x squared plus 2x plus 1 over 4x. And this is now going to be x plus 1 squared over 4x. And this is all under that radical. So the arc length now is that integral from 0 to 3 absolute value x plus 1 squared over 4x dx. All right, so let's go back over here really quick. Okay, all the values of x and y are positive, just so people know. Let's see if there's anything here we could do with that. 9y squared x. Okay. This is going to be the integral. Okay. We're going to try to do some more simplification here. So Let me do some algebra. So let's remember here. The square root of a numerator, or the square root of a quotient, is quotient of square roots. So under that radical, you have the square root of x plus 1 squared over the square root of 4x, which gives us x plus 1 really over 2 square root of x, because also the square root of a product is product of square roots. Okay. So this is some of the tools we've been using here. All right. Now, what that now gives us further is the following. This is x over 2 square root of x plus 1 over 2 square root of x. And now it looks like we're going to be able to do some simplification here. Remember, this is x over x to the 1/2, or x to the 1 minus 1/2, which is x to the 1/2. So you have the square root of x over 2 plus 1 over 2 square root of x. Now that is under your, or that's really your integrand. So let's get some more pages here. And we now integrate from 0 to 3. So the arc length is the integral from 0 to 3, 1/2 x to the 1/2 plus 1/2 x to the minus 1/2. All right, I think we could just integrate with this here. Okay. So what does that mean? We have 1/2 x to the 3/2 over 3/2 plus 1/2 x to the 1/2 over 1/2, and we evaluate that from x is 0 to x is 3. So we have 1/2 times now 2/3 x square root of x. The 1/2 will cancel here. So you're really left with the square root of x, and you evaluate that from 0 to 3. The 2's cancel as well. So you get now what? 1/3 x square root of x plus the square root of x from 0 to 3. So you now have what? F of 3 minus f of 0, which becomes 1/3 3 square root of 3 plus the square root of 3. This is my first part. Minus 1/3 0 square root of 0 plus the square root of 0. Now this part is actually 0 here. So you end up with cancellation here and here, which gives you the square root of 3 plus the square root of 3. And then at the end of the day, the arc length is actually 2 square root of 3 here. So there you go. So take a look at that. And that's the deal, ladies and gentlemen. That's the deal for these integration questions, these arc length questions.